in the Department of Informatics, School of Computer Science. It is inside the University of Petroleum and Energy Studies, Dehradun, India. Obviously, this talk is under the faculty developed program offered by the AICTE. The scheme is under the Atal scheme, and the main theme of this 5 days faculty development program is on cultivating excellence in implementation of computational science for scientific and technological innovation. And my talk is based on application of machine learning in materials engineering sector. Now, it is very popular or well known to us nowadays. Machine learning is a buzzword. The concept of machine learning, better to say artificial intelligence, is you can find everywhere. In if we segment it in era wise, so we can find that earlier days in 1990 to 2001 or 2, this era are based only mainly focusing on the application of computer science and its theory to the medical science, is not it? So, so the concept of CT scan, the concept of X-ray, and other facilities from the other facilities from the medical science, how computer science can involve. Now, it has been shown from various literature that after 2005, there is a boom in industrial automation. And whenever you're talking about the term automation, obviously computer science are there. Even in India also, according to the new education policy, things are not only the department specific. It is nowadays interdisciplinary, multidisciplinary. So obviously, to learn machine learning concept, nowadays it is not required to become a computer science engineer or IT engineer. We can learn the theory, and we can apply it into materials engineering for a better automation purpose, for reduce the timing. So my 2 hours of lecture is based on this, how we apply machine learning in materials engineering. There are I divided this talk into 2 parts. One is the basic elementary machine learning concepts. So whenever we're talking about the machine learning, obviously we have to have the clear idea about the various machine learning algorithms, how we pre-process the data and all that. And I believe many of us having this idea, but without touching this concept, we cannot start the machine learning directly. That is why I take 40 to 45 minutes for this explanation of machine learning algorithms, how they are useful in materials engineering. And then in the next part, I will describe that how we design artificial neural network and how we solve machine learning problems in the domain of materials engineering. Okay. So now, without wasting time, I jump to my outline session. So these are the topic that I'm going to discuss. A basic concept of material informatics, say why it is important, how we can solve it. Then the concept of machine learning, types of machine learning, problems, their solution, deep learning. Now, deep learning is not only basically not only means for this artificial neural network. Obviously, it is the concept of higher than the artificial neural network, where the deeper concept is there, like convolutional neural network, like some pretend network, like residual network, dense network. But as we know that this duration is limited to 2 hours, so that is why I'm explaining only the artificial neural network. And then we try to implement this ANN and if time permits, other machine learning algorithm using Python. Now, whatever the program we are going to write, that is based on the Python programming. Now, before starting this session, I also I would like to clear that why to use Python, why not any other programming language. Earlier days, C++ is the one of the programming language used to perform this machine learning or image processing based application. Now, Python is a very old language, but now it is become popular, getting popular from 2009, and it's have their own packages, own libraries. So that is why Python is going, and it is much more faster than C++. So that is why we are implementing Python, and most important thing, it is open source. MATLAB is widely popular, but we know that MATLAB is a licensable commercial software, so that is why we have to purchase it. But whereas MATLAB is instead of MATLAB, Python is better because it is open source, so there's no problem to use it. Okay, so with this, let's start the introduction of material informatics. Now, why material informatics is required? So let's start with a simple concept. Say, for example, there are several material already available from last 50 years. Say magnesium diboride. Okay, so this is a material which are already available from past 50 years, but we identify this magnesium diboride as superconductor in 2001. Similarly, lithium iron phosphate, we know it from since 1938, but it is become an Li-ion battery that come into the picture in the year 1997. So what does it mean? It means we have the data, but we don't know, or the research are not that much in this particular materials. Another example of nowadays we are trying to build in terms of material science. There is another alloy which is known as high entropy alloy, where more than more than 2, 3, 4, or 5 elements are there having the equal number of their potential. Now, in high entropy alloy, what is going to be happen? So every day we are going to create one by one high entropy alloys, and it is still in the research form that how these new materials can be designed. Now, obviously, when you're talking about the new materials, so obviously the thing is what are the properties it has. Intervention or human intervention, that means it takes time, there is possibilities of error. Now, how to rectify these errors, how to reduce this human intervention? Obviously, automation one could be the possible solution, but obviously this automation should be the error free. Now, come to the picture once again. So we are talking about this superconductor. We are talking about Li ions battery. So what does it mean? So it means that when after say in 2001 we got this magnesium diboride as a superconductor, still we need some commercialization. We need some optimization.
Professor Amita, we are not able to hear you. Hello? Professor Amita, we are not able to hear you.
this information. Similarly, just try to relate this field, materials engineering. You can find that in materials engineering also there are huge amount of data, and that is going to be wastage. So for take an example in the steel production industry, so huge amount of data is generated every day. The furnace temperature, the cooling rate, the heating rate, aligning, what are the aligning processes going on, what are the rolling processes going on. These all data are used each and every day. Now, based on this data, can we get a concrete solution instead of just put this data into when? Can we use this data to determine something? Say, for example, if we know the mechanical properties, if we know the various composition of steel or alloy, then can we find the rolling process? So if it is, then the assumption is based on the rolling, based on the composition and the other mechanical properties, we can find out the rolling process, and which could be helpful in materials industry. Okay, so these are the possible changes we can make with the help of material informatics. Obviously, this is nothing but the data, and data is not only form of textual. Data can be form of visual. That means in form of video. It can be in form of images also. Now, what type of research we can, or what type of work we can done with the help of machine learning and material science, which together combining is material informatics. So automated microstructure segmentation. So this is one of the challenging tasks. Say, for example, we have some microstructure of any alloy or say, for example, steel. Then from this microstructure, can we identify what are the phases? So we all know that there are various phases inside a steel microstructure, like ferrite, pearlite, martensite, and so on. So can we segregate these phases? So nowadays it is also there, but to understand this, we have to have use of manual intervention. Now, so for example, we have 1,000 steel microstructure images. Now, these 1,000 microstructures, someone having ferrite phase, someone having pearlite phase, and so on. Now, say for example, an expert can identify this by just seeing it. So, and assume that for particular image, we need 1 minute time to identify what phase it is. So, what happened? To understand the 1,000 images, we need 1,000 minutes time to identify each and every phases from the microstructural images. So can we implement some algorithm through which we can input our images? Based on the images, our system can generate, okay, this is the ferrite phase or pearlite phase, or we can get a concrete decision, which reduce the time, which reduce the cost also. Is not it? It obviously, when you are talking about the automated system, obviously it is reduce the cost. Cost doesn't related to always not related to the money. It maybe the time, the reduction of time is also directly proportional to the cost. Is not it? So somehow, if we able to reduce this, this could be a helpful topic. Now, another challenging area of material informatics is plasma spray coating. So in plasma spray coating, what happened that in case of high entropy alloy, it is now a very boom area nowadays. That how plasma spray can be determined based on their properties. So suppose there are thermodynamical properties, entropy, enthalpies, and based on this, how we find that which coating is good to use. Industrial automation, obviously, industrial automation is the a superset through which these all process can be done. So we are all know that IR 4.0 nowadays, Industrial Revolution 4.0. So it is always talking about the concept of artificial intelligence, how automate our industry. We are talking about new materials design, like high entropy alloy. In that also, this machine learning concept would be much more beneficial. So, for example, from high entropy alloy, you can calculate the various phases. And believe me, there are huge amount of research is going on. If you search on any good journal, you can find this topic, that how machine, through the help of machine learning, how we calculate the phases from high entropy alloy, how we calculate the structure from the high entropy alloy. So here is one schematic diagram that how material informatics going to be come into the picture. So as per this solution, you can find here that in 6th century before Christ, generally in India and Sri Lanka, steel production is come into the picture, and it is very popular at that time. Then in 17th century, Kepler's law is invented, and then 19th century, data-driven nursing is one of the main invention at that time. Then homeotherapy rules. When we're talking about this high entropy alloy, thermodynamics properties, these homeotherapy rules are obviously is very well known in material science. Hall patch relationship. So these Hall patch theories, those who are working on this domain, metallurgy or material science, they know these are very much familiar. Without these two rules, we cannot consider the concept of metallurgy, obviously. Then in the late 20th century, we can conceptualize the concept of bioinformatics, medical informatics, polymer informatics, and in the last or early 21st century, we can understand this concept of materials informatics, where we are mainly focusing the industrial automation. We are focusing the machine intervention to produce low-cost material to identify their properties. Okay, so one of my research is going on to identify several phases. Suppose this is one of the image of steel microstructure. This is one of the image of steel microstructure. Now, from this microstructure, our aim is to classify that what is the type of this microstructure. Now, what happened with these images? Actually, the problem with this kind of materials images and the other images, like, say, for example, we all know that those who are dealing with this machine learning or deep learning, they must know the concept of cat and dog classification, is not it? So in cat dog classification, the images are not that much complex, but in microstructure or in materials, each and every information are important. So to preserve each and every information, that is really a very challenging task. So feature selection, here the feature selection is one of the challenging tasks. So how we select the features? See, this suppose this is an image of steel, low carbon steel microstructure. Now from this you can find that if it is having some phases, precipitated phases, some other microstructure may looks like the similar, which is a dendrite or network type of structure. So to identify this or to differentiate between these two images, sometimes really a bit challenging. So image pre-processing, or better to say feature extraction, is one of the major important attribute which should we take care of in this section. Okay. So this is one of the growing area we can work on this material informatics. That's how we segment various phases, how we phases from steel, phases from high entropy alloy, and so on. So this is all about the materials informatics, and I try to capture the challenging areas of various problem through which machine learning can be helpful, or through which machine learning can allow to solve it at when times required. Now let's jump to the machine learning. So in several books we can get the several definition of machine learning. This is not again I'm telling you that machine learning is not a new things. We already know the terms support vector machine. Those who are related to this term, the KNN, the K nearest neighbor, decision tree, all these are very old techniques. But the concept of machine learning is concept of, say for example, we are how our machine going to learn. It is similar to a very small child, how he or she learn by seeing the objects. So more and more objects visualized by the child, more and more object he or she can predict, is not it? So machine learning is something like that. So based on data, so using data, we can train the machine, and now we are going to take the answer from based on the data. So this taking the answer is known as the prediction. So our aim is to first train the data. So train the data means we train the machine and using the data, and then train the machine using the data, and then based on the training we can calculate the prediction. Okay. And obviously whenever we are talking about the how prediction is accurate, so there are some indexes as there are possibilities of uh, uh, data overfitted, underfitted. So we have to check these also, but these are the very basic terminology that I have discussed as of now. When we're talking about the machine learning, obviously we have to understand the type of machine learning problems are. So there are three types of machine learning problem. One is supervised, another is unsupervised, another is reinforcement learning. So supervised learning means someone is supervised this, is not it? Say for example, when your output is known. So output is known, that is known as a supervised learning. So for example, we have a animal image, and now our aim is to understand that whether this animal belongs to cat or dog or not. Okay, so that means the output class is defined, that cat and dog. So whatever image I have, it must belong to either cat or dog. Maybe it is wrong, but it should belong to any of this class. Okay, that is the concept. Similarly, for email spamming, so whether my email is spam or not, we can also predicting the values, continuous values, like predicting the house price, stock price. In terms of if you try to relate this, we can predict the various phases of microstructure from microstructural images. We can predict the BCC, FCC, that is the crystal structure from solid solution. We can do that, where your classes are BCC, FCC, and so on. Based on the input parameter, you can find the structure. Okay, so this is the supervised learning. And when we're talking about the supervised learning, it is also again two types. One is classification, another is regression. So classification means it is where we when we're dealing with the discrete output variables. So discrete output variables means, say, ferrite phase, perlite phase. So what are the different phases? So then it is known as a discrete variable. Now regression means when we're talking about the continuous. So for example, we are trying to predicting the yield strength or elongation from other mechanical properties, okay, or the UTS, uniform tensile strength. Then how we then this type of prediction technology is known as regression. So where we, for layman understanding, when we divide our when the output is based on some class, then it is known as a classification. When we are talking about the numerical value prediction, then we can say it is okay regression. So numerical value prediction means it is a continuous, so that means it is regression, and class prediction means obviously it is a discrete. Now, another type of machine learning techniques is unsupervised learning. So in case of unsupervised learning, there is a no desired output. Okay, there is a no desired output. So based on the training data, we learn something and we can create some assumption. Okay, now we have to check how close my assumption is with respect to the actual assumption. So obviously here to understand the actual assumption, it obviously bit difficult because we don't know the actual solution of it. So so for example, clustering is one of the unsupervised learning technique. Okay, so when we're talking about the clustering, say based on the shapes, we are going to predict the square. Okay, so it's going to learn the square shape first, and then it's going to predict whether the given shape is a square or not. Okay, but here the output is not specified. So this is one of the example of clustering unsupervised learning. Say there are some few dot points. Based on the dot points from a sample space, it's going to be divided into say red segment, blue segment, and green segment. So now we have to check that okay, how close it is towards the actual understanding. Okay. The third type of machine learning concept is known as reinforcement. Now, reinforcement is one of the most challenging techniques in case of machine learning algorithms, machine learning problems. So, there is an agent who is going to interact with the environment and watches the result of the interaction. Now, what does it mean? So, based on trial and error method, it tries to learn and then it gets some reward. So it is based on the reward. So reward means what? From this image, I just try to, if you're when we train a dog, so for example, if our dog able to catch the ball, so we can reward a biscuit. Okay, so this is a kind of reward. Okay, so in reinforcement learning, where based on the various trial and error method, we can come into the solution, and when the solution is achieved, we get reward. Okay, so this rewards in terms of accuracy. Okay, now there are different different types. Now each are having their own understanding that when to use supervised, when to use unsupervised, when to use reinforcement learning. So for example, if I simply classify when my classification techniques or classification outputs are known, then we go for the supervised. When it is unknown, we go for the unsupervised. When I simply depends on trial and error method, then obviously I go for the reinforcement learning. Okay, so these are the various types of machine learning problems. Now another steps. So we find the different types of machine learning problems. Now we have to solve it. Now these 5 steps are really very much important. Each and every step are equally important. If we miss any of the step, maybe our prediction accuracy hampered. Okay, so first step is data gathering. So as I told you earlier also, that data doesn't mean only in textual form, it could be image form, in visual form. It can be structured data, it can be unstructured data. Structured data means whenever it is row and column format, like Excel data or CSV file, it is having structured data. Now, unstructured data means what? Unstructured data means where it is not in row and column format. Like, say, suppose you get the information from some images or so for example, when we're talking about the Twitter or Facebook, the social networking site. So one commenting, someone commenting a post, and then the reply is going on that particular comment. So this is not follow any structure. Okay, so this is known as the unstructured data. So based on the unstructured data, we can clean it, we can derive it. Now, when we're talking about the unstructured data, then big data concept is there to handle this. How we handle this unstructured data. And in that case, MongoDB is one of the solution, or for analysis, Pig is one of the solution. Pig is one of the solution for handling unstructured data. Now, another kind of data is there, that is semi-structure. Semi-structure means it is sometimes it's behave like a structure, sometimes it behave like a unstructured, like HTML file, XML files, JSON files. So these are the, if we are taking the data in form of HTML files or CSV files, so then not CSV, sorry, XML, then it is unstructured, sorry, semi-structured. Okay, so there are three types of data actually: structure, semi-structure, and unstructured. Structure that we really generally use, that is the in row and column form. Okay. Now, data pre-processing. Second step is data pre-processing. Data pre-processing is again one of the very much important terminology. Here we pre-process the data. We try to find out the missing values. We try to find out the different null value. Clean the data. So these things have been processed in this case. Feature engineering. Now, feature engineering means that how or which feature is important. So, for example, we have 10 numbers of features to represent a prediction. Now, out of which, out of these 10 features, which are really very much important. So we use those features. We more emphasize on these features only, not the all 10 features. And if all 10 features are required, then we obviously go for it. And then the algorithm selection and training. So algorithm selection means there are several algorithms already available. Now, what is the one of the main advantage of machine learning problem nowadays? Already these algorithms are defined. We have to call these algorithms and we can design it. We can use it directly. Now, obviously, there is a scope of improvement in everywhere. We can design our own algorithm also, if we can. So obviously, it is very much helpful to the society as well as the industry. And based on the algorithm selection and training, we can going to evaluate our model. That means we can making the predictions. So data gathering, these things I have already discussed in my last slide. So you can gather the data. The data obviously in the raw format. Say for example, we gather the data from any steel production house, the various temperature, mechanical properties, compositions. Okay, and from this we are going to predict the say rolling process. Okay, so this is how we can gather the data. Data processing, we can use the missing values, outliers, bad encoding. So bad encoding is for text. Generally, we are dealing with numerical data, but sometimes it might happen that in your Excel sheet or your CSV file, the data in textual form. So obviously, to convert it from textual to your numerical data, we can use encoder. So one hot encoding is one of the technique through which we can use this encoding. Wrongly labeled example. So sometimes it might possible that your data is wrongly labeled. Wrongly labeled means suppose your output class is not. Suppose there is some image of cat, but it is labeled as a dog. Okay, so this is simply wrongly labeled concept. Now, the concept of feature engineering. Feature engineering is obviously to understand the features, extract the features. In when I discuss the uh, implementation part, I will explain each of this terminology very clearly. So these are the list of machine learning algorithms are available. Uh, One is for supervised learning, name-based classifier, linear classifier, decision tree, support vector machine, random forest, k nearest neighbor. These are very much useful. Whereas neural network is also useful as a supervised learning. Principal component analysis, stochastic nearest embedders is T-shape, obviously. T distribution is known as. It is also very popular unsupervised learning. K-means clustering is one of the example of unsupervised learning. Whereas SARSA lambda is reinforcement learning, and Q learning is one of the example of reinforcement learning. So these are the algorithm under various machine learning types. Okay. Now I'm going to use that how we can simply identify this model, or how we use the prediction. So simply we have a model, say for example, there are X and Y. These X are several input features, and Y is our label. So label means what? Label means simply the output class, say whether it is a cat or dog, whether it is a ferrite phase or perlite phase or button side phase, something like that. So we train this to our machine that okay, these are the phases of these are the output classes we can have, and there are samples. Samples means this is the X is the sample. So from X we are going to collect the features, and then these features feed to the machine learning model. So machine learning model having the algorithms, say for example, if it is a deep learning concepts, a neural network is there. So neural network try to understand these, and based on your learning, it try to get the levels. So from here you can get accuracy that is known as a training accuracy. So much more training accuracy is obviously good enough to understand that machine learn properly. Now, what happened in case of prediction phase? In prediction phase, it is again we pass the inputs, say the raw inputs, and then from the raw inputs again we are going to extract the features. These features to pass to the trained classifier. Now, this classifier going to understand that okay, based on the learning from this machine learning model, it is going to be classified which level it is. Now, it obviously based on our learning, it's going to be attached to a level. Now, this level may be correct, may not be. Okay, so our aim is to achieve the correct level at the end. Much we more we achieve the correct level, that more accuracy we can get simply. So that is the obviously our aim also. But it might possible that sometimes we deals with some lower accuracy. So then in that case we have to do some hyperparameter tuning and all that. So this topics at a glance, simply the concept of machine learning. It is use of data to answer the question. Simply. It is three types: supervised, unsupervised, and reinforcement, and five thumb steps that we have to use. One is data gathering, data pre-processing, feature engineering, algorithm selection and training, and making predictions. Okay, so these are the part of machine learning techniques. Now, as I'm discussed that I am going to discuss about artificial neural network. So I would also explain that what is artificial neural network is. But before that, I just explain. I try to understand that how we implement stress strain curve okay, stress strain curve with the help of some data. And then I come to this deep learning session. Okay. Okay. So I have already prepared this. So I'm just showing you that how we can formulate basic how we can formulate the concept of stress and strain and plot the curve with the help of machine learning model. Okay, so here we have two CSV file. One is for steel 1045 and another is for aluminum 6061. So there are two CSV file, raw CSV file I have. So these are the raw CSV file. These are available on internet also. And you can find from your available sources. Doesn't matter from where you get this data. Okay. Um, so these are the raw data simply. These are the, if I open it, you can find these are the simply raw data. So these are the simply raw data, and these are having some meaning. Now each and every column having some meaning. Now a materials engineering guy obviously understand the meaning of this, the meaning of this each and every header. Okay, now from this we are going to calculate the trace and strain. So obviously to understand this we need not to bother about the machine learning, the algorithms and all that. But we have to understand how we focus the formula in case of Python. Now in Python there is a library named pandas. I will explain the pandas library in just after a few minutes. As of now, you can understand that these are the Python packages or libraries. With these libraries, we can input this CSV file. Okay. So these two libraries, we've taken these libraries as the CSV file as input, and we just try to understand that what are the different columns or information are there. Only first 5 information have been printed here. Now something that our aim is to identify the stress and strain. So from here we are going to calculate or going to use 3 columns. One is force column, another is extensometer column, another is CH5 extension column. Okay, so the formula you can find that if you find this epsilon percentage is into 0.01. So strain can be calculated strain percentage into 0.01. So this is how you can calculate the strain. So you get the CH5 column. So all the attributes of CH5 column, and then it is multiplied with 0.01. So this is the formula simply. And then we calculate, we fixed a diameter, say 5.506. So this diameter is also given. And then you have to calculate the stress. So stress, how you calculate the stress? So simply you can calculate this force into 0.001, force into 0.001 divided by A0. A is the area, cross-sectional area. Okay. So here you can find that A0 is defined by pi into diameter by 2 whole square. So this is, you can write pi into diameter by 2, and asterisk 2 means it is a whole square. Okay. This is also whole square. It is not 2, it is a whole square actually. Okay. So this is how you can calculate the strain of a steel. Now, similarly, you can calculate the strain of alloy. So this is the formula is same for whether it is for steel or whether it is for aluminum. The formula is same for each and every case. Is not it? Now, see here you can find that we call one more library, which is known as matplotlib.pyplot. So this is the package which is very much helpful to print the or to display the graph. Okay, so here I'm drawing this graph based on this data. Okay, so we get this strain steel and trace steel, similarly strain of aluminum and trace of aluminum. So once you get this data, then you can simply put the graph, say how you this is how it looks like. So this is not the concept of any machine learning techniques. Okay, but from here we can, from this graph or from this information, we can design the machine learning. That is I want to say. So that how if our data are available, based on these we can plot the data and we can calculate each and everything, whatever is required. So if we know the formula, it is similarly to in very basic centigrade to Fahrenheit temperature when we in when we in engineering. So we used to learn the C programming, and there is a concept of how write a C program to convert centigrade to Fahrenheit. So if we know the formula how to convert centigrade to Fahrenheit, we can easily do it. It's not it. So the thing is similar in this case also. If we know the formulas, then we can easily calculate this trace strain with the help of programming concept. Now later on, this concept, how we input this to a machine learning system, that is our aim. Okay, how we use this strain or this trace to evolve another properties or to understand the mechanical behavior or grain distribution, if any. So based on from this we calculate the stress strain, and then we can use this data to my next level. Okay, so this is the concept of this is the main purpose of showing this stress strain curve. Okay, now again back to this discussion. So now I'm talking about the neural network. So in neural network, what happened? We all know that the concept of neural network is basically the human neuron or human brain, similar to human neuron. So it has some axon dendrite who receive the signal through the synapses, and then it passed to the neuron, and then action going to be taken. Okay, so this neuron sometimes known as nodes. So we pass several signals to the nodes through the synapse. So and based on these signals, we come into the output. So this is the simple structure of how neuron is looks like. Now, say for example, here I use several inputs variables, say x1, x2, xm. It's inputted to this neuron, and these lines are known as synapse, and then we are predicting the output value, that is known as y. Now, what is this x1, x2? These x1, x2 are the independent variables. Independent variables means they are not dependent to each other. And when we're talking about these independent variables, we have to standardize it because they are not in same scale. So our aim is to scale it. We have to standardize it. So the standardization means the mean is 0 and standard deviation is 1. Okay. So we have to do this, perform these operations, and then we can based on this we can get some output. Now this output could be continuous. Continuous means when it is we are going to calculate the price, . So these are the continuous value. So we can get a single continuous value. We can binary, say yes or no. We can get the categorical data, say for example, whether it is ferrite phase or pearlite phase or martensite phase. Okay, so these are the three types of output we can generate. Now, how we do this? So there's a basic formula. So this formula is where, say for example, x1, x2 are the input parameters, and you can get some. You have to assign random weights. Say w1, w2, w3 are the random weights. So this multiply to each other and come into here. So from here, x1, w1 come and get a information, give an information to the neuron. Similarly, w2, x2 come and give some information to neuron, and similar wm, xm comes and gives some information to neuron. So we can say that this is something like that w summation of wi xi. Now, this is one information. Now, second information is there is a concept of activation functions. So what are the activation functions? Activation function means through which our model get understand so what to perform and how to perform. Okay, so for example, there are four types of activation function. One is threshold. So threshold means if some if your output class or if your activation function or neuron, better to say, try to predict whether it is 0 or 1 or not. So simply 0 and 1. Okay, so that is we go for, in that case we go for threshold function. Sigmoid is also for 0 and 1, but it is some bit probabilistic. Probabilistic means suppose where our value after execution we get a value of say for example 0.8. So okay, 0.8 is probability of 0.8 to closer to 1. So that is why you take 0.8 is say 1 instead of 0. So there is a probabilistic value we get taken. So it is also lie in between 0 to 1. Okay. Whereas in threshold, it is either 0 or 1. Okay. But in case of sigmoid, it is a probabilistic value in range of 0 to 1. Okay. ReLU is one of the rectifier unit, linear rectifier we can say. It is a max of x comma 0. So x is the maximum value and then generally we use ReLU in the intermediate or hidden layers. And another high probability tangent, it is for minus infinity to plus infinity. So if our range is wide, then we go for tangent. But generally we use these two, sigmoid and rectifier. Okay, these are the some really good resources to understand this rectifier units. So in hidden layers, this ReLU is generally used, and for output layers, we are generally use this sigmoid. Now, one thing should keep in our mind that sigmoid means it is for binary data. Okay, say for example, whether it is 0 or 1 or not. Okay, so only one output is there. That there might possible the outputs become more than 2. Say output layer become 4 or 5 labels. Say for example, ferrite, pearlite, martensite, woodmanite, and so on. So in that case, instead of sigmoid, softmax we are going to use. Okay. So this is so for example, for this one we consider this is the first layer or input layer. This is the second layer or the first hidden layer, and this is the output layer. Okay. Now try to understand a basic problem that through how we can design a neural network from basic. So for example, we have some petal, and we have the length of the petal and the width of the petal, and there's this petal having two class. One is either red and either or blue. Okay, so if the petal length is 3 and petal width is 1.5, it is red. If the petal length is 2 and width is 1, then we can say this petal color is blue color, and so on. And finally, suppose this value is not present in our data. Suppose 4.5 the length of the petal and 1 is the width of the petal. This combination is not present. Our aim is to predict this. Okay, tell me what is the color of this petal if the length is 4.5 and width is 1. Okay, so how we do that? So before doing that, we just assume that this is the textual value, red and blue. I assume that 1 indicates reds and 0 indicates blue. So we manually assume that, okay, if my result comes near to 1, we can say it is a red petal. If my result comes near to 0, then we can say, okay, it is a blue petal. Okay. So this is the 2 input solution. So there's a 2 input length and width, and 1 output is the color. Okay. So we can get this. We get 1 and 2. What would be the output? Okay. So we have to put this W1 to weights, random weights. We have to put here and here. So how your color function works? So it is obviously sigmoid we have to use, because it is either 0 or 1, or it is either red or blue, something like that. So we calculate the sigmoid of length into W1 plus length width into W2, and some bias is going to be added. I will explain why to include the bias. Say the sigmoid of 2 is this value for these, and W1 is the random value, 1 is the value for these. So 1 into W2, and we add some bias. Bias is also random value. And say, for example, we get this W1 value is 0.5, W2 value is 0.2, and B value is 0.3. And we can say, okay, we get a value, say 0.82, which is near to 1. So that just means it is, we can say this is nothing but the red color. Okay, so we can say this is a red color. So just check 2, 1 and 2, 1 is red color or not. Say 2 and 1 is a blue color, which is not red color. So my prediction is not correct. So let's try to formulate it. So let's try to solve one example.